Do you know how to convert a mass percentage into moles? Hopefully you figured out that you can use the molar mass of the element. Let's take a closer look at how to find the empirical formula of hydrogen peroxide. From experimental data, we know the mass percentages: 5.94% hydrogen and 94.06% oxygen. Because a percentage is based on 100, we know that a 100-gram sample of hydrogen peroxide contains 5.94 grams of hydrogen and 94.06 grams of oxygen. To find the number of moles of each element, we divide the mass of each element by that element's molar mass, which gives us about 5.88 moles of each element. Now that we know there are 5.88 moles of each element, we're almost there. To find the empirical formula, we need to determine the smallest whole number ratio of the elements. To do that, divide the larger number of moles by the smaller number. In this case, there's no larger and smaller. The numbers are the same, which is a ratio of 1 mole of hydrogen to 1 mole of oxygen. The numbers in the ratio become the subscripts in the empirical formula. So that means it's HO. Now that we have the empirical formula, how do we get to the molecular formula? We need to find the whole number N that, when multiplied by the empirical formula, gives us the molecular formula. We'll use molar mass again, only this time it's the experimentally determined molar mass of hydrogen peroxide, 34.02 grams per mole. We also need to calculate the mass of 1 mole of empirical formula units. We get that number by adding up the atomic mass of both hydrogen, which is 1.01 grams per mole, and oxygen, which is 16 grams per mole. That means the molar mass of hydrogen peroxide is 17.01 grams per mole. Now, let's find the whole number N by dividing the molar mass of the compound by the molar mass of the empirical formula unit. That gives us 2 as the whole number N. Finally, we multiply all the subscripts in the empirical formula by that number. And there we have it. Ta-da! The molecular formula for hydrogen peroxide.